Okay, so here we can see the beginnings of the Cellweb installation for tree root protection. This is the TPO tree with its root protection area. Building a private driveway. First thing we see is the geotextile fleece. Now this is non-woven, needle punched geotextile. As you can see, on the ground it has been overlapped by 300mm to ensure there are no weakness in the joins. Now this fleece is for a separation layer, as it can mould and deform to the shape of the clean angular stone infill, which we'll see go in on the next video. But it's also pollution control. It's been tested and proven at the Coventry University to be able to hold 1.7 litres of oil per metre squared. It has a high tensile strength of 23 kilonewtons and also a CBR minimal puncture resistance of 300 newtons. Now each panel of Cellweb, this is using the 100mm depth Cellweb, which is applicable up to a 6-ton gross weight. So for private driveway, cars and transit vans, this is the perfect product. You will notice the green identification strip. This is for ease of identification of our product, Cellweb. Now each panel, first of all, a peg has been put into the middle of the panel there, which you can see. The panel is then pulled out to its full 8.1 metres length. Adjacent pegs are then put into the corners at 2.56 metres wide. So it's 8.1 by 2.56 metres. This gives the perfect cell diameter for dissipation of the vertical load. And as you can see, there are two panels together here. Each adjacent panel will be stapled together to create one continuous mattress of dissipation of the vertical load. Now here you can see a shape from where the tree is. Again, the panel will still be pulled out to its 8.1, which is what was done here. This gives it the correct cell diameter, and then the shape is then cut around the tree. So you cut out the shape that you are required. This is still in the beginning of the installation. We're not ready to infill yet. The panels do need to be pulled around a little bit, ensure that every cell is at its correct diameter. But this here are the shapes of the diameters you're looking for. Diameter of the cell, technically, needs to be 259mm by 224mm. Now this is the optimum cell size for dissipation, and it's the only cell size that has been independently tested for tree root protection. This is why we at Geosynthetics are the only company who are able to offer a 20-year guarantee on our products. This guarantee, it covers the Cellweb itself. Should it fail, we would obviously replace, but it also covers protection of the tree itself. And we will pay up to £10,000 should Cellweb be failing, and that failing be responsible for tree decline. 20-year guarantee. Most road design lives are for 20 to 25 years, so that's what it's covering. Again, these cells, they need to be moved about. We're still in the first stages of putting these and pegging these out, but it's looking bang on at the moment. Have a bit of a shift around, continue with all of the other cells, and then we'll infill with the clean angular stone. A little bit more detail on the Cellweb. Here on the Cellweb wall, you can see these perforations. Now if you didn't have these perforations, there'd be no lateral migration of moisture or air, which would lead to areas in the construction starved of oxygen and water. Now obviously that would be catastrophic to the tree root's health. Also, it works the opposite way around for soil respiration, where carbon diffusion can happen and carbon can be released from the soil, can still come through the clean angular stone infill and through these perforations out into the atmosphere. Again, I'm going to see if this works. It's not going to zoom in very well, sorry, but with the clean angular stone infill, it can actually protrude through the perforations. This helps lock in the clean angular stone and helps dissipate the vertical load laterally via the sow walls into the next sow that contains the same angular clean stone. And this is what helps dissipate the vertical load laterally along the system as opposed to the ground below. Now, you're not going to see it because it won't zoom in, but you'll hear it if I run my fingernail across. That's because there are little ridges on the Cellweb wall, again to aid in the friction of the clean angular stone. Now, these perforations, they are 11% of the Cellweb wall. This is the optimum perforation for both permeability but also for structural strength of the Cellweb wall. If you increase the percentage of these perforations, it could lead to weakness in the wall and lead to tearing, ripping and failure of the system. So ours is 11%, which is the optimum percentage of perforation. So you can see sow has been shifted around. Every sow is on the correct diameter. If I get a video of the dumper truck coming in, as we have the infill of the clean angular stone being raked just above the Cellweb walls, so the dumper isn't driving on the Cellweb itself but on the clean angular stone infill. Dumping down. There you go, ground's been identified, filling that spot first. Again, dumper can move forward. This shows how quickly it can dissipate the vertical load laterally along its system. Construction traffic is able to move along the Cellweb to actually installing it, supporting the construction traffic being used to implement it.